Hello everyone. Today we are going to cover the merge sort algorithm. In our previous video, we have covered that quick sort algorithm. So, as always, before going deep diving into the coding, let's first start. Let's first understand the problem and the algorithm, how we are going to solve it. So for that, let me just quickly go to the Eclipse, and I have already added this placeholder code from our previous algorithm because we needed to print the array. Then this function will be to merge sort the driver program, and this will be merging our array, and then this will divide and this will merge. And here is our algorithm. I have just written quickly. So what is going to happen is first we will call this algorithm recursively. So let's say first we have a full array, whole array, this 2, 3, 4, 5, 6, 1. So we are going to call this algorithm for the start from here. So let's say our array is the whole array, and the left is 0 and the right pointer at here. So it will be the array dot length minus 1. So if our left pointer is less than the right pointer, so if our left pointer is here and right pointer is here, then it's going to perform the operation. So there will be four steps. In the first step, what we are going to do, we are going to divide the array in two parts. So it's a merge and conquer. So first we are going to divide the array. For that we have to find a median. So it will be left plus right divided by 2. So our mid array, the middle value will be the 4, which is index 2. The second will be to divide the array in left half. We are going to call the merge sort with the left half. So it's like divide the array in left half and call merge sort. So in what we are going to do, we are going to call merge sort with our left half of the array. And then in step third, we are going to call the merge sort again recursively with our right half part of the array. So to calculate the left half, we just simply do left minus the middle. So we will receive the size of the array. So it's 0, 1, 2. So size of the array is 3. And then same as right side array will be 3. Then it's going to call again and again, and this will be divided into two part. This will be the median, and it will divide it into two part, 2 and 3 and 4, and the same way. After that, once this is called, left divided into left half and divided into right half, then we are going to call the merge on both the divided parts of the array. So left half and right half is going to be merged together. And what we are going to, when we are going to merge our array, we are going to check if the first element is less than the first element of the right side. So what we are going to, we will choose this and put it in the final array. Now we are going to track if 3 is less than 5, yes, then put it in the target array. If 4 is less than, then yes, put it in the target array. Now left array is completed, so there is only right array is left. So what we are going to do, we are going to put completely the same array in the target array. So let's just see it quickly in the Excel. So this is our whole array. Then it will be divided into the left part and right part. Then it keep dividing itself. So it will become 2, 3 and 4. Then the right side also become 5, 6 and 1. Then it will become, then these array next become the 2, then 3, then 4, the array itself, and they will have only length of 0. And once we are checking if left is less than right, then we are not going to call the algorithm again. So our recursive calls will end there. After that, this is going to start merging. So if you see how it will merge, then it will do 3 and 4, then 1, 5, 6, because this is the left side and this is the right side for this one. So 1 is less than 5, so it will be first in the target, then 5, 6. After that, these are also going to get merged, and finally our array will be sorted. So let's see it in the graphical view. It's better to understand that. So this is taken from the gig for gig. So this algorithm is going to remain the same. So what we are seeing here is that this is the median, and then it will divide it into two part, left part and right part, and then it keep dividing itself until it becomes the length of 1. So this will be divided into 9 and 82, and it will also divide it into 9, 82 and 10. Everything will become one size array. After that, when its length is 1, what we are going to do, we are going to start merging it. So the merge function will call itself recursively. So 27 and 38, which one is shorter? So 27 is less, so it will come first in the result array, then 38. This will also get merged and in the sorting order. Now we have this array, this will be left, this will be right. Then it's going to again merge in the result array with the sorting, and this will also get merged with the sorting. Now we have the final array, and it will also be merged into this array, which is finally the sorted array. So this is the algorithm we are going to cover with the code. So let's jump into the code and start coding. So first, what we have to do is always we need an array. So first, let me declare an array. Array equals to new. We will take size of 10 for initial. Now we need to generate random number, so we don't have to fill the array all the time. Equals to random, and this is going to be imported from java.util. Then we have to generate a random array. I mean fill the array. So for loop and I equals to 0 less than that our new array dot length, then I plus plus. Now the value of array I will be equal to the new random, so it will be rand dot next 8, and what we are going to do, we are going to generate the values between 1 and 100. So 100. Now our array is 100, so let's print it first. System out. So this is before sorting. Print array. Let's run our program. So as you can see, the array is not sorted. Before sorting, it look like this. It is always going to be generate random number, so you don't memorize the output. Now what going to happen next is we are going to call the merge sort. So it will be merge, then it will first input will be the always not called merge. We don't have anything to merge. Our array is not divided yet. So let's call the driver program for once the merge sort. Now it will be the first parameter will be the array, then the left index initially will be the 0, and the right index will be the array length minus 1, which will be the last item's index. So it will be array dot length minus 1. Now what's going to happen is we will print our array when it's sorted. So let's just sort our array first. I don't want to print it. Now we have the merge sort, we have to implement the program. So what was our algorithm? That until the left is less than right, then only keep this running. So the first condition will be if left index is less than, greater than or equal to right index, then it's going to return, and do not continue the recursive calls. Now we need our middle value to divide the array. So it will be middle index. This is merge. I have to code these things in merge sort. These are the drawback when you use the placeholder code. So index and index. So these were our initial index when we start calling the recursive calls. Now I need to calculate the middle index. The index, which will be low index plus high index divided by 2. I want it to be precise, so yeah, it's low index. Of course, it needs a comment. Now, what is the next step? In first step, we call the left side, then we recursively call the right side. We already calculate the middle, so we call left side, then we call right side. So let's call our array recursively. Merge sort, then starting will be the original array, and then the left index will be low index, and the right will be the middle index. Is we are going to like divide the array. So lower index will be like 1 and middle index will be like the middle value of the this array. So it will divide it into the left half. Now we have to sort the right half. So then we should then it will be the middle plus 1 because the left array is middle is the last item. So it's the right side array starting position will be the middle plus 1. Middle index plus 1. Now we have high index, which will be the last index of the right side array. Now dividation is done. It will call recursively itself and keep printing the left and right side of the array. So save it, and now what is going to happen when we sort the left array, when we sort the right array? Now we need to merge it. So let's call the merge. So it will be the array, then our the left index will be the low index, then middle index, and it's going to be the high index. So we can keep track of which one is the left array and which one is the right array. So low index to middle index is the left array, and from middle index to the high index, from middle to the high index is our right side array. Now let's write our merge function. So what we need to do inside our merge function? Yeah, we didn't discuss our algorithm. In merge array, what we do, we merge left side of the array and right side of the array. That's simple. And what we do, we take the smallest item from left side and right side and put it in the result. Once both are sorted, and if there is any value left in the left or right side array, we append those values in the result array. So let me create the left side array size. So we can create an array of left and right. So that left array size will be equal to the middle index minus left index. So let's say our array will be like size of 3 or 4, depends on the input. Now right array size will be equals to the right index minus middle index. Now we have the array of the size of the left array and size of the right array. Now we have to create the array, left array and right array. So left array equals to new left array size and right array will be equal to new right size. Okay, now we have left array and right array. What we need to do now? We have to put the values in the left array and right array. So we will fetch the value from original array and then keep adding inside left array and right array. So we can after that perform the operation like merging of left array and right array by sorting it, then appending it into the final array. So what I'm going to do for I need variables. Okay, I can declare with I equals to 0, I less than left array size and I plus plus. Now the left array I equals to the original array, then original array is that value which will be the first index of the left array. So it will be the left index plus I. Now we need to fill our right side array. So for int I equals to 0 less than right array size plus plus again, and then I'm not forgetting something. No, so right array will be I equals to array right index plus I. Now here is the twist, that the left index, the middle index is going to end. So when we divide the array, middle index will be the 0, 1 and 2. Now what we have to do, we have to start a loop from here when we are filling our right side array. So what we have to do, we have to do middle index plus 1. So then we are going to start from here. So where is our function? Then it will be plus 1, then plus I. I can print the arrays, print array, right array, print array. This will be the left array. And if we check the output, we can see the left and right side of the array. So this is our input, and index 10 out of bound for length 10 0 now. See this, the array is going to be divided into 45, 58, 51, then 45, 96. Something is wrong. It have to be divided into the bigger parts. It says line number 35. Right array equals to array right index plus 1. Yeah, array always start from the left index. I mean, for the left side, it will start from the left index when we start filling the array, and for the right side array, it's obviously going to start from the 0th index. So for it, it will be middle index plus 1. Yes. Now I guess it's fine. Yes, perfect. Now I can solve print array. Let's just print the right side of the array. So as you can see, right side will keep dividing itself into 60, 56, 51, 94 and 47. So this will be the right side, then it keep dividing itself 94, 47, then 47, 51 itself, then 56, then 6, 80, and it keep dividing itself until it just the one size of the array. Now what we have to do, we have the left side and right side of the array. So the next step will be taking the values from left side and right side, comparing them if they are less than or greater than from each other. Then if they are less than, then put them into the main array, and if it is greater than, still put them into the array but at the different position. So while, let me first declare the tracker. So int left array index tracker equals to 0, and right array index tracker equals to 0, and the main array tracker, main array index tracker will be equals to the left index from where our array started. So now while our left array index tracker is less than the size of itself, when we keep moving the pointer in the left array like 0, 1 and 2, so it should be always less than left array size, and the right, same for the right side, right array index tracker is less than the left array right array size. Now here we are going to match if the values from left array first element and right array first element is equal to each other or not. So if left array index tracker is less than or equal to the right array right index tracker. If this is the case, then what we are going to do, we are going to put the current left side element into the final array. So our main array, then main array index tracker will be equal to the, it's going to equal to the left array. Let me just copy paste this. This is too much of. I have lost the recording because I have pressed one of the hotkey of the OBS Studio and the screen just switched to the Google Chrome. So I'm recording it, actually recording it again from where I have left. So let me just copy it. So the left array, the main index array will be the item of the first index array. So the first value of the left index, left side of the array will be here. Let me put a here so I can see, you can see clearly in the OBS Studio. Now, when this is the case, we are going to increment the pointer of the left array index tracker plus plus. But if it's not the less than, then it's greater than. So what we are going to do, we are going to copy it, then paste it. Let me see if OBS is still recording. Yes. So we are going to do right array index tracker, and also the right array will be equals to the right array index tracker. So the if it's greater than, then the value from the right array will be added to the main array. Now, once this is done, left array tracker is +1 or right array is +1. What we have to do, we have to increment the pointer of the final array. So I'm going to do the main array index tracker plus plus. Now, after this, our left side array and right side array are sorted, but there can be case where some values will also be left on the left side of the array or the right side of the array. Let's say left side array is 2 size and right side array is 1 size. So, and right side array is the greater than. So what's going to happen? It's going to right side plus plus, and this loop will become false here and it's exit. But still there are 2 values in the left side. So what we have to do, we have to put those values in the main array, so they can be sorted in the next round. So let me code it quickly. The condition is going to be same while, and I will increment it. Now I will increment the right side if there is any value left in the right side. Now this should be solved, but there is also one thing remaining, which is if we are taking things from the left side of the array and putting in the main array, then we have to obviously increment the main array. So it will be the main array index tracker plus plus. And I don't know the hotkeys of this. We can do things very easily in VS Code. That is different scenario. We will discuss sometime later. But now our algorithm is working. So let me just quickly run it and see if it's working. 0, 11, 12, 36. Yeah, it's working. So our array is sorted. So it just sorted it in just time. Let me do things for 100,000 and generate the value between 100,000. We know array is sorted. We just want to see the timing. If it's quicker than quick sort or no. Okay. It's taking time to print the array. let me, I cannot stop it, just leave it, we don't want to do the time comparison right now. So this is our algorithm, this is our recursive call which we are going to call merge sort. Here you can see we call the merge sort for left side, we call the merge sort for right side. So we call for the left side, we call merge sort for the right side. Now once we have the array divided in left and right side, what we are going to do, we are going to merge those arrays. So we are taking those array input here, and then we are making a left array and right array. Then we are filling those arrays with the values from the main array. So we can have like this is the left side array divided and this is the right side array divided. So our main array, now we are taking some pointer for the left array pointer and right array pointer and the obviously main array pointer. Now what we are checking, if the value of the left side of the pointer is less than the right side of the pointer, if this is the case, then put the value in the main array, otherwise put the value of the right side array in the main array. Now increment are the tracker of the main array, and if anything remaining after this operation in any of the array, left side or right side, any value is remaining, then what we are going to do, we are going to put those values in the main array again, and this is going to call itself each and each again until the whole array is not sorted. So again, too many values with I called, reduce it to 10. Now our array is sorted. See. And the runtime of this algorithm will be n log n always. In the best case, worst case, average case, always it's going to be n log n. But it's going to take an extra space, which is this one. It's going to take for each call, it's going to create an array, and this is it. But our quicksort algorithm was doing it in just in space. That space was, it's not taking any extra space or auxiliary space. It was doing it itself on the O1 that and this is having the time space complexity of O1. So this is it for today. Thank you for the watching or your patience to watch me or the programming, and see you in the next video. We will cover some next different algorithm. Till then, bye.